Hi, today I will talk to you about the new PL3 and its software. The PL3 scanner has a brand new design. It has 3 cameras. The top and bottom camera are used to scan geometry and surface of the object. Around the cameras are infrared lights to be able to see the targets placed on the object. In the middle, there is the camera that captures texture and color. Around the camera, there is a ring of LED lights. Right over it, there is the infrared projector. The infrared is projected as a series of lines over the surface of the object. On the back of the scanner is the LCD touchscreen. The LCD touchscreen will display information as you are scanning. You will be able to change settings while you are scanning. You'll be able to start, pause, zoom in, zoom out, change the shutter speed. The scanner is connected to your computer via USB, and on the same cable, there is the electrical connection. Calibrating your scanner before starting a project is very important. This will ensure that your scanner will be optimal when scanning. To do the calibration, you can follow the instructions on the screen. You simply take out the calibration plate, place it over the box, and position the scanner in the same way it shows you on your screen following the little Go scanner. Make sure the X and Y axis are aligned and that you are pointing at the center of the plate. Once there, you simply pull up your scanner and follow the scanner on your screen. The calibration can be done once a week if your scanner is always in the same environment. If you are changing environments, for example, if you are in the lab in the morning and then in the afternoon you must go outside and scan, you will have to do a second calibration in the second environment. If the scanner is always in the same environment, the calibration can last up to 7 days. After 7 days, the software will let you know when it's time to do a new calibration. Preparing an object before you start scanning is very important. The PL3 is very good at scanning objects that have lots of geometry. It will use the geometry to position itself in space around it. If your object doesn't have a lot of geometry, you will need to place a few targets on its surface. Make sure to place the targets on flatter areas and not too close to edges or highly curved corners. A few targets here and there is going to speed up the scanning process. Before you start scanning, you must select the parameters. Start by selecting the size of the object that you will be scanning. Are you scanning something tiny as a chess piece, something small, medium, large, or are you scanning a human person? Then select the size of the details of your mesh. How small are the details of your object that you are trying to capture? Are they very fine, smaller than 4 mm, fine between 4 and 8 mm, normal between 8 to 15 mm, or coarse larger than 15 mm. You could also manually customize the resolution that you want for your scan. Then you can select the output. Do you want your scan to be balanced, using the optimal settings to produce the best mesh within a reasonable processing time? Do you want it enhanced, where the data will be analyzed and processed to reduce the scan noise and sharpen the edges, where it might take a little bit longer? Or do you want to go quickly with the Express and use the minimal settings to speed up the processing time? Or are you looking to send it to a 3D printer by making it watertight, making sure that all the openings are closed? Lastly, you can select if you want to scan without color or with color, with high resolution or low resolution. Once you have selected the parameters, click on Next and go to the scan step. Now, to start scanning, place yourself in front of the object, about 30 centimeters or a foot away, and press Start. As you start scanning, you will see the object appear on your screen. You can see that there are some lines on the surface of the object with different colors. The green means that you're at the right distance from the surface that you are scanning. The red means you are too close and you have to back away a little bit. The blue means you are too far away and you have to get a little bit closer. Make sure that you're always in the green zone while you're moving around your object. You will see those same colors in the back of your scanner on the LCD screen. Try to stay as perpendicular as possible to the surface that you are trying to scan. You can move around your object if you need to, or if you have your object placed on a turntable, you can rotate it. When encountering small holes, try to scan in all directions to get as much inside of that hole. The smallest hole you can scan with the PL3 is a hole of 3 mm in diameter. Once we are done with our first scan, we can then click on Next, and it will take us to the Clean step. In this step, we can start cleaning our mesh and removing all the unwanted data. It will create a clipping plane and remove the background. Start by removing the background, and then you could select the data that you want to keep and the data that you want to delete. In this project, we're going to flip our object around and scan the other side to be able to merge them together and have a complete scan. We then click on the plus button and it takes us back to the step to be able to scan the other side that we want to merge. We repeat the scanning process. For this side, when scanning for a merge, we have to make sure that we have common surfaces that are captured on both scans to be able to help the pre-alignment for the merge. When we're done with our second scan, again we clean the scan, making sure we remove all unwanted data and click on the next step to go to merge. Thanks to the targets on the part, the pre-alignment was done automatically. It recognizes all the targets on the object on both scans and brings them together. We then go to the next step, which is the align. Once in the align step, the origin of our scan is placed in the center of mass of our object. We can now select the alignment that we want by constraining it with axes or planes with geometrical entities on our object. I prefer to align my scans in PeelCAD. In the improve step, we have different functions that allow us to improve our mesh. We could create some distances by selecting 2 points. We can then clean the mesh by deleting the abnormalities created when the mesh was generated. We can fill some holes completely, partially, or create some bridges. We can decimate our mesh by reducing the number of triangles while preserving the original shape of our geometrical features. We could smooth the surface of our mesh to reduce the effect of noise and roughness on the mesh. We can sculpt by engraving or embossing directly on the mesh. We could also edit boundaries, modifying the shape of the triangles along the boundaries. We could also remove some spikes by detecting and flattening each spike separately on the mesh. If you did not scan with color, you can click on next and it will skip the colorize step and go directly to export. In the export, we can select if we want to export our mesh directly or if we want to send it to PeelCAD module. By selecting export, we will be able to export our mesh in different file types. The most common one used is the STL. By clicking on export on PeelCAD, it will create a copy of our scan and send it to the PeelCAD module. The PeelCAD module is our reverse engineering bridge module. It bridges the world of a scan to a CAD environment. In this module, you will be able to align your scan, create geometrical entities such as points, lines, circle, planes, cylinders, spheres, cones, even create cross-sections, silhouettes, and find the pipe center lines. You'll also be able to create distances and angles, and you'll be able to create NURB surfaces that are workable in CAD environment. You have different tools to delete, to copy, to cut your mesh. You could again clean your mesh just as you did in your previous module. We have the same tools that we found in the Improve section as we had in the Improve step in our PeelOS. You could also edit your mesh by creating a shell or offset. You can extend the boundaries, cut the mesh with a plane, make it watertight, sculpt your mesh. You could also scale your mesh if you need to. You could extrude boundaries. You could cut your mesh with a curve, or you could flip or fix the normal of your mesh. If you have various scans, you could bring them into PeelCAD and compare one mesh and the other and find the 3D deviations from one and the other. You could also combine different meshes together and create one STL file. Or you could also merge them just as we did in the previous module. Once we imported our mesh into PeelCAD, we can start creating all the geometrical features that we need. We could start by creating planes and a few cylinders and use those for the alignment. After we have created our new alignment, we can start creating all the other geometrical features that we need to transfer to our CAD software. We can create 2D, 3D features, and we can also create NURB surfaces. You can see I selected a part of the object, copied it, and created a NURB surface out of that section. Once I have created all the features that I needed, I can select all entities in my navigation tree and transfer them directly to SolidWorks. In SolidWorks, they are imported as native features and I could edit them directly. I can also go back to PeelCAD and export my features as IGES, STEP, CSV, or DXF. As we saw with the Peel 3, we can scan, clean, merge, align, improve our mesh, send it to PeelCAD, and create all the features that we need for our reverse engineering. I hope this video has helped you understand how the Peel 3 scanner and the software work and how it could benefit you and your projects. Thank you.